Okay, Mr. Trutna here. How you guys all doing? Good to hear. Super happy to hear that you guys. Faith, happy that you're good today. Elise, thank you for asking me how I am. I am fine. Today we're going to go over section 8.4. We're going to go over compositions of isometries, okay? And so that brings up two definitions that we're just going to quickly glance over. So an isometry is a translation, a reflection, and or a rotation, okay? And when we do isometry, it could be more than one, okay, movement in a problem. Okay, more than one movement in a problem. So what we're saying is an isometry could be a problem where we do a translation and then a rotation in the same problem, or we do a reflection and a rotation in the same problem. Okay, a composition of isometries means that we're combining two or more isometries in one problem. Okay, so what we're going to be doing today is we're going to be working on these compositions. And basically what that means is that we're going to be doing two of the movements. Remember, the three movements that we've been working on in class are translation, reflection, and rotation. Okay, and we're going to be doing two of them in the same problem. Okay, and there's going to be 4 examples that we're going to work on. So as you can see in the very first example, we're going to start off with triangle JZL. You can see that Z has coordinates of -4, 0. All right. J has coordinates of -5, -2. And L has coordinates of 0, -3. So what we're going to do is that we are going to translate this shape 3 units to the right, and then we're going to and up 4, and then after that, then we're going to rotate it 270 degrees counterclockwise about the origin. Okay, so what we're doing is we're going to take our X and our Y values, and the first thing that we're going to do is hold on, we've got to listen to the speakers here.
If you're still on campus, please report to the library at this time. Nathan Beck. If you're still on campus, please report to the library at this time.
Sorry about that. I had to walk outside for a quick second. My barbecue was lit, and I had to make sure that it wasn't going to catch on fire there. I'm barbecuing a little bit of Santa Maria tri-tip. Yep, Isaac, I like that stuff too. Okay, so anyhow, we're going to take these points and we're going to translate 3 units to the right. So what does that mean? We're going to take the X value and we're going to add 3 to it. And then we're going to go up 4. Okay, so what does that mean? When we go up 4, it means we're going to take the Y value and we're going to add 4. Okay, and then after that, notice that it says, then we're going to rotate 270 degrees. Okay, so when we rotate 270 degrees, the formula for rotating 270 degrees means that we're gonna using the rotation rules, we're gonna get Y and then -X. Okay, so let's go ahead and let's do these points and let's see what happens here. So let's start with point Z. So let's take the X value, which is -4, and let's add 3 to it. That would give me -1. Then let's take the Y value, which is 0. Let's add 4 to it, and that would give me +4. Okay, and then we're going to do the 270 degree counterclockwise rotation, which means that we're going to take these points, these coordinates, -1 and 4, and then we're going to follow the rule of the 270 degree rotation, which would mean we would get coordinates of 4 and +1. So that's going to be my Z prime. So my image of Z is going to start at -4, 0. I'm going to move it 3 units to the right, which means I'm adding 3 to X, up 4 units, which means I'm adding 4 to the Y, and then I'm going to rotate it 270 degrees, which means that I flip these numbers around and I take the opposite of the X. Okay? So then I'm going to do the same thing for J. So I'm going to see where my image J prime ends up. So I'm going to start with -5. I'm going to add 3 to it. That's going to give me -2. Then I'm going to take my Y value, -2. I'm going to add 4 to it. That's going to give me +2. Then I'm going to follow the rule of the 270-degree rotation, which means I'm going to flip the two numbers around, but I'm going to take the x value and make it opposite. So this would become 2, positive 2. So J prime would have coordinates of 2, positive, and 2. Okay, doing the last point, which would be L, I start with the coordinates of L, which is 0, negative 3. I'm going to move it right 3. That means I'm going to add 3 to the x, so that would give me positive 3. Then I'm going to go up 4 units on y, so it's at negative 3 plus 4, so that's going to move me to 1. Okay, and then I'm going to do my 270-degree rotation, I'm following this rule here, which would change these coordinates to 1 and negative 3. Okay, so then what I do is I'm going to plot these points, and that's going to be my point for L prime. Okay, so Z prime is at over 4 up 1, right there. J prime is at over 2 up 2, that would be right there. And L prime is at over 1 and down 3. So this is L prime, then we have J prime, and then we have Z prime. Okay, and then when we connect the points, Mason, we use a straight edge to connect the points so that it doesn't look like like an earthquake hit in the middle of you connecting the points here. And that would be my composition of, this would be my image of my pre-image, and this is a composition. How did I get that? Well, I translated this shape 3 units to the right, I translated it 4 units up, and then I rotated it 270 degrees counterclockwise. Okay, so let's go to example number 2. So you can see in example number 2, I'm going to first reflect over the y-axis. Okay, so that's going to be my first movement, my first transformation, and then I'm going to translate up 2 units and left 2 units here. All right, so I'm going to take my points, C and J and K and M. I'm going to put what the coordinates are. So C is at negative 3, positive 1. J is at 0, 1, coordinates of 0, 1. K's coordinates are positive 1, negative 1, 2, 3, 4. So positive 1, negative 4 for coordinates of K. And M has coordinates of negative 4, negative 2. So whenever we're doing these movements, any of the transformations or any combination, the first thing we're going to do is you want to write down the coordinates. Okay? Then we're going to make a rule. Alright, so I'm going to start with my x and my y, and my first thing I'm going to do is I'm going to reflect over the y-axis. So remember, when we reflect, my y-axis is my line of reflection. Okay, so what I'm going to do is I'm going to write the new coordinates of what each one of my points is going to be. Okay, so I'm going to reflect over the y-axis. So J won't change at all. So you can see my first thing is that when I reflect, J is already on the y-axis, so the coordinates of J are not going to change. Okay, C is 1, 2, 3 units to the left, so that means when I reflect, C is going to end up right there. Well, what are those coordinates? That is 3, 1. So C is going to become 3, 1. And if you notice, the x value was opposite, but the y value stayed the same. So I'm going to make the x value opposite. I'm going to have the y value stay the same. So that means when I reflect K over the y-axis, the x value is going to become opposite, so that would be negative 1. The y value, negative 4, is going to stay the same. And if you look at this right here, here's K. When I reflect it, K is going to end up over there. That's negative 1, negative 4. Okay, M, which has coordinates of negative 4, negative 2, is going to end up over here, which is coordinates of positive 4, negative 2. So M is going to have coordinates of positive 4, negative 2. Okay, am I done? No, that was my first reflection. That was my first movement, reflect over the y-axis. Okay, then I have to do it again. Okay, now I'm going to make another movement. What's my other movement? I'm going to translate up 2 units. So that means I'm going to add 2 to the x. Okay, and then I'm going to go left. Whoops, I'm sorry. I'm going to go up 2 units, so that means I'm going to add 2 units to the y, and then I'm going to go left 2 units, so that means I'm going to subtract 2 units from the x. Up means I'm adding 2 to the y. Left means I'm taking away 2 from the x. Okay? And so that will give me where my final points are. So I'm working off of these values here. So to find my x value, I'm going to take my x value, which is 3. I'm going to subtract 2 from it. That's 1. Then I'm going to take my y value, which is 1. I'm going to add 2 to it. That is 3. So my c prime is going to have the coordinates 1 and 3. Okay, following along here, to find j prime, I'm going to take my x value, 0, subtract 2 from that. That would give me negative 2. Then I'm going to take my y value, which is 1. I'm going to add 2 to it. That would give me positive 3. So my j prime would have the coordinates negative 2, 3. Following along here, to find k prime, my x value, negative 1 minus 2 gives me negative 3. My y value, negative 4 plus 2 gives me negative 2. So k prime would have the coordinates negative 3, negative 2. And then m prime, my x value is 4. I'm going to subtract 2 from that. So that's 2. Then I'm going to take my y value, which is negative 2. I'm going to add 2 to that, and that's 0. So m prime would have those coordinates. Okay? So then to show my movement of reflecting over the y-axis, and then translating up 2 units and left 2 units, I would plot the points. So c prime is over 1, up 3, right there. J prime is negative 2, 3, so that would be left 2, up 3, and we're always going from the origin. K prime would be left 3, down 2, 1, 2, 3, down 2, there's K prime. And then m prime would be over 2, up 0. So this would be m prime. This point right here would be k prime. This would be j prime. And this would be c prime. And once we plot all 4 points, get out a straight edge, connect all the points together, and you would see what your image from your pre-image looks like. So this is what the shape would look like after I reflected my original quadrilateral over the y-axis, and then I translated it 2 units, up 2 units, and left 2 units, okay? And once again, because I did 2 movements in one, that's called a composition of isometries, okay? So Kaylee, what does composition mean? It means more than one. In this case, we have 2. Excellent answer there, Emily Caldwell. Sit down. Thank you very much, Emily, for just staying in your seat and working on getting all of this stuff down. Okay? All right, we're continuing to take notes. We have 2 more examples to go. So here you can see we have triangle JKV. Okay, so J, first thing we want to do is we want to write the coordinates. So J's coordinates are negative 1, negative 2. K's coordinates are positive 2, negative 4. And V's coordinates are positive 4, negative 1. Okay? And then we're going to look and we're going to see what type of transformations, in other words, what type of movements are we going to make. Well, the first thing we're going to do is we're going to reflect over the x-axis. Okay? So let's do that first. And you can see we're going to do more, but I'm not going to worry about the more yet. So I'm going to reflect over the x-axis. Okay? So I'm going to take my x and my y coordinates, and then I'm going to reflect them over the x-axis. And then we're going to see what the coordinates become. I'm actually not going to draw the shape yet because I'm going to make more than one movement. I'm going to make a what, Kaylee? A composition of movements. That means I'm going to make more than one there, okay? All right, so reflecting over the x-axis. So here's my x-axis. Remember, whenever you do a reflection, you want to get out a highlighter, highlight in your line of reflection or your axis of reflection. Okay, so where is J going to be? Well, you can see that J is 2 units below the x-axis. So now I reflect it, J is going to end up 2 units above, right there. That's the coordinates of negative 1, positive 2. So J's coordinates are going to be negative 1 and positive 2. So what happened to the coordinates? Notice the negative 1 stayed the same, so the x values are going to stay the same, but then the negative 2 became a positive 2, so that means we make the y value opposite. We're going to follow this rule. That's the rule for when you reflect over the x-axis. So that means k, which is at 2, negative 4, following this rule, that would be 2, positive 4 for k when I reflect. V, which is at 4, negative 1, following this rule, x stays the same, 4, y becomes the opposite, so it's negative 1, so that would be 4, 1. Okay, well that's my first movement. Am I done? No, because it said reflect over the x-axis. I just did that. That's going to give me those coordinates. It says then rotate 90 degrees counterclockwise. Okay, so my next movement is I'm going to rotate 90 degrees counterclockwise, okay, about the origin. So what's the rule for when you rotate 90 degrees? You got to remember that rule. Look it up in your notes if you're not sure. So the rule for a 90-degree rotation is we're going to go the opposite of the y value and then x. So in other words, I'm going to take these numbers, I'm going to flip them around, and I'm going to take the y values opposite and keep the x values the same. So that means my j prime, and I'm not going to do any more movements after that, so I'm going to be done. So that means my j prime coordinates would be, I'm going to follow this rule here. It would be negative 2, comma, negative 1. Notice, take the opposite of the y value, 2, becomes negative 2, keep the x value the same. Okay? That would be j prime. All right? Continuing on that rule, this is my 90-degree counterclockwise rotation rule. Okay, so 2, 4, what would it become? It would become negative 4, positive 2. That's what k prime would be. Okay, and the last one, what would the coordinates 4, 1 become when I do a 90-degree rotation? It would become negative 1, positive 4, and that's where my v prime would be. Okay, so I'm having to do 2 rules, one at a time, and I do whatever this problem says to do. Now I'm going to plot these. So j prime is at negative 2, negative 1. There's that point. K prime is at negative 4, positive 2. So that would be that point right there. I'll fill in the letters afterwards. And then v prime is at negative 1, positive 4. Okay, so we have v prime right here. Then we have k prime here. And then we have j prime right here. All right, awesome. The lights just went out. Okay, hold on. I got to walk around for a second. All right, good. All right, I had to flip my tri-tip. Get it on the other side. Okay, remember, tri-tip. You sear on one side whenever you're cooking a tri-tip. Sear on one side for 10 minutes. Sear on the other side for 10 minutes. And then turn down the heat and just cook on one side for 35 minutes. Okay? So there you go. Barbecuing by Mr. Trutna. Okay, so there would be my image of my pre-image. How did I get that image right there? Well, I reflected this shape over the x-axis, and then I rotated 90 degrees counterclockwise. Okay, last example, we're going to take my original, I got my triangle right here, B, N, X. I'm going to write down the coordinates of my pre-image. Okay, B, 1 to negative 4, positive 1. N has coordinates of negative 5, negative 4. So N, negative 5, and negative 4. And then X's coordinates are negative 3, negative 2. Okay, so I'm always going to start out by writing down my coordinates of my pre-image, which is going to be the shape that you start with. Okay, then I'm going to look. So what type of transformations, in other words, what am I going to do? Well, my first movement is I'm going to reflect over the y-axis. Okay, so I'm going to do a reflection. So here's my y-axis right here. All right, and then I'm going to reflect it. I'm not actually going to draw the shape because I'm going to have to do another movement after that. But let's go ahead and let's try to figure out a rule for when I do a reflection. So let's look at B to help me find a rule. So if you notice, B is 1, 2, 3, 4 units to the left. When I reflect it, B would end up 4 units to the right of my line of reflection. So what are the coordinates of that? That is positive 4, positive 1. Positive 4, positive 1. Well, what happened? The negative 4 became a positive 4. The positive 1 stayed the same. How would I represent that as a rule? That would be the opposite of x, comma, y. Notice, took the x value, made it opposite, y value stayed the same. Okay, so I'm just going to follow this rule to write the coordinates of point N and point X. So following that rule, I'm going to take the opposite of -5, which is +5, leave the -4 as is. Okay? For X, I'm going to take the opposite of -3, which is +3, leave that value as -2. So that's going to be my reflection. Okay? Now I'm not going to plot those points. Why not? Well, because you can see I'm going to do something else. It says then I'm going to translate up 2 units, and left 4 units. Okay, so how am I going to write that? Okay, so how do I write that? All right, well, first of all, I'm going left 4 units. That means I'm going back this way. So I'm going to subtract 4 from my X value. Then I'm going to go up 2 units. So that means I'm going to add 2 to whatever my Y value is. Okay, so how do we read this? Remember, that means left 4 units, up 2 units. That's how we represent that translation. So now, and after that, I'm done. So now I can figure out where my B prime is. So I'm going to take my X value, which is 4. I'm going to subtract 4 from that. That's 0. Then I'm going to take my Y value, which is 1. I'm going to add 2 to that. That's 3. So B prime is going to have the coordinate 0, 3. All right, then I'm going to use, for find N prime, I'm going to use the coordinates 5, -4, because that's what happened after I did my reflection. So I'm going to take my X value, which is 5, subtract 4 from that, that's 1. Then I'm going to take my Y value, which is -4, add 2 to that, that's -2. So my N prime coordinates would be 1, -2. We do the same thing to find my X prime coordinates. Take my X value, which is 3, subtract 4 from that. 3 minus 4 is -1. Then I'm going to take my Y value, which is -2, add 2 to that. -2 plus 2 is 0. So my X prime coordinates would be -1, 0. So what do I do, Jade? Plot the points, connect them with a straight line. Good. I don't know if you heard Jade said that. Couldn't hear very well. She's over there working on my tri-tip right now. Jade, don't flip the tri-tip yet. Okay, good. All right, not yet. 15 minutes. Remember, sear it. Both sides, 15 minutes. So 0, 3. Let's plot the points. Over 0, up 3. Put a point. Plot the point. 1, -2. Over 1, down 2. Okay, I'll put the letters in. I'll put the B prime, N prime, X prime in a second. -1, 0, right there. Okay, now I'll put the values, or the letters in. So that's X prime. 1, -2 is N prime. 0, 3 is B prime, and then I use a straight edge and I connect the points so I can see what my image looks like after I do this double movement. What's a double movement called if you do more than one movement at a time, Kaylee? Kaylee, seriously, I've asked you the same question 3 times. Yeah, composition of isometries. When you do more than one movement, it's called a composition. You could see that would be my image of my pre-image, okay? All right, so at this point, your teacher, that'd be me, Mr. Trutna, is going to give you a worksheet. You're going to work on the worksheet, okay? And so for the rest of the class, this is what you're going to do. You're going to work on worksheet. Okay, and let's see, the worksheet is, hold on 1 second, it's been 15 minutes, so I got to flip my tri-tip, I got to sear it, okay, so I'm going to sear my tri-tip once again onto the other side, okay, you're going to do worksheet, sorry, I got confused here, so you're going to do worksheet 8.4, and you're going to do numbers 1 through 13, so 8.4. You're going to do numbers 1 through 13. When you get that done, after you get that done, then you're going to go to Math Excel for School. On the laptop.com, and you're going to do Unit 8-2, Unit 8-3. Okay? So do the worksheet first, and then do the Math Excel. Okay, talk to you guys later.